Hello and welcome to this keynote session, forming part of the 12th Annual Analysys Mason Telecoms Summit. My name is David McElroy, and I work as part of Analysys Mason Online's events team. Now, you may have already watched some other sessions leading up to this one. However, I just wanted to go through a few points that will help to make sure you get the most out of this and all of our other summit presentations. Firstly, I would like to remind you that all sessions are available on demand, which means that you can access them in an order, at a time, and on a date that suits you. We have a selection of keynote and breakout sessions for you to choose from, and you can access all of them via the event homepage. Once you have entered your chosen session, you have the ability to connect with our presenters on social media, access useful resources, and submit questions. Please use the console widgets that you can see in front of you to submit your questions. Now, as these are on-demand sessions, our presenters will pick up your questions and respond to you directly via email in the coming days. And once the session is ended, you'll be redirected to the event homepage and able to select another session. And now I have the pleasure of introducing partner, Chris Bow. So Chris, over to you whenever you're ready.
Thank you, David. And it's a true pleasure to join you today. I'm the head of NSR and also a partner at Analysys Mason. And it's my honor to speak to you on a topic that's very near and dear to my heart, which is the use of satellite and space technology to actually connect via the telecoms world. This is a topic I've covered for approximately 25 or so years now. It's quite a long time, but the era now we're in, it makes this technology and satellite and space technology more relevant than ever to telecoms. So the saying goes, if I have done this presentation 5 or 7 years ago, this will be a very different talk to you. And many of the beliefs that you may have had about the satellite and space community would have persisted then. Satellite being high cost, not quite applicable in terms of supply, very limited reach, worst case scenarios. All of those things were once true. The goal I want to show you today is to really, with some key points and 3 key points I'm going to make, to show you that the time is different now. This is a different era. It's a new era, as they say on the slide here. But to give you some more food for thought, so you should really think about satellite in a different light now. And if you had those preconceived notions before, maybe time to think about them a little differently. But first about us. So we at NSR, our goal is to cover everything in satellite and space, from users on the ground up to the farthest reaches of our universe, solar system, whatever you might term it. Now, we spend a lot of time in the satellite world. That's the vast majority of what we do, is covering satellite technology. And that's everything under the sun, from video broadcasting to data. We work with a lot of users, cruise companies, governments, et cetera, on strategic planning. And of course, the telecom community who are looking at satellite and space sort of strategic moves. Now, we were founded back in 2000. So just this past April, you may have seen the news, we were acquired by Analysys Mason. We brought our global team of satellite experts and space experts into the Analysys Mason fold, which is a tremendous fit for us given, again, this theme we're on today. Our senior team, very detailed and experienced, slotting right in with all of the other areas of research that you're probably familiar with, that you're hearing really today at this conference. So we're excited about this opportunity, excited about what it brings our clients and what it brings the Analysys Mason community, being you. So without further ado, I want to jump into what the themes are of my talk today. And I have 3 key themes. And again, we could talk for days and days and days on satellite and space, but I think for you, this audience, I want to really highlight 3, which are, first of all, the fundamentals are absolutely changing right now. Very different era now, very different dynamics in terms of a few key metrics that I want you to consider. Next, constellations. And this topic, constellations, are groups of satellites that exist in orbit that have a mission, usually communications. Some are for Earth observation, which are taking pictures of the Earth and monitoring and sensing, et cetera. This is a major, major disruption in our part of the industry. So in the satellite world, it's completely upset the paradigm. And also for you as sort of maybe non-space, primarily non-space players, this is a very big disruptor. And lastly, this crossover point we want to highlight of a few key themes, and it's very, very current things that are happening in news, trends, et cetera, about satellite really crossing into telecoms more and more. Making, we like to use the word mainstream. Very important themes to think about. So we'll start first with the first theme, which is the fundamentals are absolutely changing. And I want to show a quick quote here from Telefonica. You would know the name, Latin American telco. We work with them primarily on a lot of satellite activities, but they also are pretty large telco. But very similar to these trends that we're seeing. The last decade, satellite really has reinvented itself lots of times, but satellite solutions really were only the last option. They weren't viable technically and or economically. It really was the alternative when nothing else was there and you had to connect something or use it. But that basically old paradigm, as they say here on the slide, is being shot down before our eyes. Latency, we talk about signal, basically the latency of a signal in but satellite terrestrial has come down significantly. Prices come down significantly. SLAs have gone up, supply's gone up. We're in the midst of this new era. So let's look behind some of the data points of what really show that. First, if you took everything that NSR does and boiled it down to a few key data points, which is a really good scene setter for the rest of the talk. From a revenue perspective, we project of a cumulative number over the next 10 years of about 1.2 trillion US dollars. That includes everything from the Starlinks of the world and satellite connectivity to remote users up to space stations to lunar transport. I mean, just about anything in space is covered in that number. The number of satellites to launch, 33,000, and that number goes up every single week, month, quarter, year, whatever. It is a absolute, if you do a 10-year rolling number, 10 years into the future, that number goes up. And again, that is a significant departure from where we've been, where we were launching very big, a couple of hundred big satellites to geostationary orbit, which is what you're probably used to. And then from a traffic standpoint, 570 exabytes of traffic in the satellite and space world, again, from comms to sensing, imagery, all of the above. It's a pretty enormous number, and it's growing all the time. Now, relative to the telecom world, it's certainly nowhere near size and scale, but the curve points pretty much straight up for all three of these metrics right now. But some fundamental changes. We talk about architectures in space, and we show here the traditional world where if you're connecting from a satellite to a vessel in the middle of the ocean, you'd use a traditional satellite. These satellites exist in, I mentioned, geostationary orbit, so as the Earth turns, the satellite goes with it, so you can use a fixed antenna on the ground. These satellites are very, very inefficient for data, but they're great for video. Video broadcast, you can light up any household or cable downlink site anywhere within that beam and you can broadcast video. But if you're trying to just serve that one vessel in the ocean, very, very inefficient. And again, satellite companies have adapted these signals to data. Fast forward now to the high throughput satellite world, which is a term that we coined many years ago because analytically it's just a different way of counting capacity. Take that same footprint and divide up into multiple, sometimes hundreds of beams via frequency reuse. It allows you to be much more efficient, dramatically increase your supply of capacity that you can actually provision across the entire old blob that goes down into multiple small spot beams, and really designed for data-centric applications. And data-centric applications are the growth story in the satellite world. Video is great. We still do a good job supporting video, but data is the growth story. Next, we're moving closer and closer to Earth. The traditional satellites, and there are still some new HTS satellites from a variety of companies, Viasat, Hughes being the biggest players in GEO with big high throughput satellites with that new architecture. But as we move further or closer and closer to Earth, medium Earth orbit, there is one constellation of satellites from O3b, and if you know the name SES, which is a big satellite operator in Luxembourg, that's their play in the constellations world, and they have another network called Empower coming to that altitude. But going down further, LEO. This is there's a term for it, the LEO economy. So much is happening in LEO nowadays, and the name SpaceX, I'm sure you're aware, and Starlink exists in that series of orbits, much closer to Earth, much lower latency, Now, when you move closer to Earth, you need more satellites for global coverage. Now, in GEO, you can cover the globe with 3 satellites, give or take. When you move to LEO, it's significantly more. So from a CapEx spend, it does increase, but from a bandwidth and latency perspective, and then, of course, price, very, very advantageous. But this is where a lot of the activity is happening. And we say multi-orbit. The operation strategy is multi-orbit. So satellite operators today that own infrastructure are not just placing their bets in one, they're placing them in multiple. And that's a very good move based on traffic performance, traffic profiles, those types of things, that one may work better in one orbit than the other. Along with that, we've taken an absolute turn upwards in terms of the availability of capacity and supply increase. And we've been eking along as an industry at a few hundred gigabits per second of global supply today, for years, not today, but since 2000, goes back even further than that when I entered the industry. We launched some big GEO satellites around the late 2009, 10, 11, 12, somewhere in that era. You saw a lot of these big GEO birds coming along. But over the last couple of years, it's that LEO business that we talked about, and primarily Starlink. Of course, OneWeb has, if you know the name OneWeb as well, has taken a role in this, but it's primarily Starlink that has really dramatically increased the availability of global supply. Today, it's around 39, give or take, terabits per second of global supply. And in the next 9 years, well, actually 8 years now, 172 terabits per second. So this is a step function that is just not seen in the traditional satellite world. And I think we as a satellite industry are trying to keep up with, okay, what's the demand curve look like as well? And we're trying to match those two together, but it's an exponential increase of supply. So again, this is not the satellite world of yesteryear where it was high latency, not too available. That world is changing. As well, pricing. And NSR, I mentioned we work with end users quite a bit. We work with operators too, and everything in between to understand contract terms, pricing, et cetera, for a variety of customer types. And these are really the big four here that if you take all of the data and look what's happened since 2017, price has really fallen quite rapidly in the satellite world. Video is again, pretty much a stagnant from a growth perspective application for all of the trends that you can imagine, cord cutting and competition, et cetera. So been dropping almost 44%. Enterprise data, your classic enterprise connectivity, where enterprises may use a contended or uncontended service, but that as well, given the supply picture that we showed, has fallen over 55%. But these last two are really interesting. When we get to backhaul and broadband, and backhaul, satellites being used to backhaul signals to cell towers. And today, there are hundreds and hundreds of transponders being used for just satellite backhaul. So this is an interesting one. As the demand curve has risen, price has fallen to the other side because supply. You try to triangulate that all together, it gets you to about 70% decrease in price. Again, there are a lot of reasons for that as well. Being competitive, bargain sort of driven pricing to the telco community that is basically make or break, meet a price point or we can't do the deal. But again, 70% reductions. And lastly, the maritime and the energy business. Energy for a couple of years has been not so great. It's coming back for obvious reasons, commodity prices going up. And maritime community, imagine a cruise ship. If you've ever taken a cruise, how much capacity do cruise ships use? Again, 44%. So this is all positive momentum in the direction we're seeing, again, making it more, back to the word, mainstream. And then viability. And the satellite backhaul world is increasingly more viable, as I mentioned. And this is a real example. I can't speak in generalities, but I'd like to dive in and give you an example of a client that we had in Brazil who was looking to connect, say, 10 or 12 or so sites. And they were considering fiber versus a LEO, back to LEO, HTS backhaul, so via satellite, so backhauling via satellites down to the ground. And we ran an NPV analysis of this, and it was showing that, again, the biggest sort of swaying point in all of this is, of course, bandwidth cost. And by getting bandwidth costs down, we used a Monte Carlo analysis here to show with real certain terms that when that bandwidth cost came down below, say, 65, 60 US dollars a month, it became a very possible and positive business case. So this is one example. We've done this analysis. We've run these clients in Alaska, clients in Asia, Southeast Asia, and elsewhere to show what's that crossover point that satellite becomes more cost effective. And it's becoming more and more positive for satellites over time, given the metrics we discussed. Next, we're going to talk on constellations as disruptors. And the disruption theme is prevalent throughout the conversation today, but especially this topic. And I'm sure you've heard the name Starlink, you've heard the name SpaceX. They're the most visible one, but not the only one. But they are disruptors. And the point here is, yes, that's true, disruption, but we're in our first phase of disruption. And I'll walk you through that of why. So who are the big players, the ones that maybe household names to those maybe you haven't heard of as much? So, of course, SpaceX and on the top left. And every one of these pictures is a fully deployed constellation map. When they have all of their satellites deployed in different inclinations, which they're not just going around the equator or the poles, they may be, different inclinations or different altitudes. This is what the networks look like deployed. So Starlink, thousands and thousands of satellites. Amazon Kuiper, if you've heard the name, Amazon Kuiper is something that will take full effect in the next, say, 4 or 5 years by the time that they have good momentum in terms of launch. But they're interesting because they also have a launch company that launches rockets, basically people and satellites. And of course, AWS. So they've got a very interesting sort of ecosystem at play with Kuiper that I think is still taking effect. Lightspeed from Telesat, a Canadian operator, building a satellite network for mainly high-end users, some governments, but those satellites are actually interconnected in their first generation. So they're not just bouncing signals up and down, they're actually speaking across space. OneWeb as well, UK, they went through bankruptcy, came out of bankruptcy, funded by the UK government and other strategics. They're in their first generation of deployment, but their next generation, same with Starlink, will have that cross-link capability. And then a topic that's really positive and very interesting today is the direct-to-handset business from space. And Globalstar and Apple made some big news. We'll talk on that in a sec. But of course, others like AST Space Mobile is launching a constellation for this application. Link is another, LYNK. These are big plays, full authorization coming or already granted in some markets. But again, there's a lot of disruption happening in this world. But the next slide really shows what's it like today. And we look at these satellites as the Starlink satellites in yellow deployed today. SES-03B, which I think includes some Empower satellites that are coming, which again operate around the equator. And then OneWeb satellites, and OneWeb, being higher on so polar and other routes. So think about aeronautical traffic going over the poles, or think about scientific research. There's an interesting market there. But over 2,000 satellites already deployed today in this first tranche of constellation evolution. So you see Starlink and SpaceX launching every 6-7 days sometimes on average this year. Constantly launching, landing a rocket, having another one ready to go. And that cadence will continue. But as we said, we're in our first generation of capacity provisioning. The one thing I want you to understand about constellations is that it is very, very inefficient capacity, okay, in its first generation. So think about bouncing signals up and down to get between 2 points. These satellites don't talk with one another. So if you're in one region to the other, you have to bounce down to a gateway and maybe backhaul or maybe continue bouncing, depending. But we wanted to run the analysis to show, okay, how much is actually applicable to you, if you're using or working with constellation companies. At the ITU level, 1,444,000 gigabits of capacity is filed. So these are applications that have been filed at the ITU for authorization. Now, that's not authorized at the local level, so you go to the FCC in the US or Ofcom in the UK. It's not, we're just saying macro, this amount of capacity. We then take that analysis, that capacity number, and bring it another level down of what do we think is actually going to launch. Of course, the ones we mentioned are going to launch in some shape or form, most likely. Some of those in that last slide, we'll see. But we do feel it's about 380,000 gigabits per second. But when we move over ocean versus land, 70% of that capacity is over 3 ocean regions, the Atlantic Ocean, Pacific Ocean, and Indian Ocean. Yes, there are ships there. Yes, planes traverse those oceans. But again, in its first generation, how to connect those when you have to bounce signals constantly. And the rest is over land. So really only of that capacity, 20 to 30% of it being sellable. So there are supply challenges. In the US, when Starlink became oversubscribed, they had to do some changes in how they provision. And that's not easy, and of beams filling up, et cetera. So it's not a very efficient in its first generation. And if we take just Starlink now and apply that principle just to Starlink of today, when the full generation 1, we call it Gen 1 system launches, it's a good about 40 terabits per second, 40,000 gigabits, so 40 terabits per second of capacity. But we have a toolkit that we use for each of these analyses. It's really an interesting toolkit, and we can talk to you offline about it. But it does simulate over any country, any region, whatever, what's overhead, exactly how much capacity is overhead. And you start to think, okay, well, Russia and China, for obvious reasons, not markets that Starlink is able to play in. And a market like India, which has a big demand for connecting the under or unconnected. That number is probably on the low side. Now, there are regulatory challenges in India, but it's probably on the low side. Brazil, definitely on the low side for this first-gen constellation. US, probably more trending on the low side to, then Canada trending probably just about right, as they say, the Goldilocks syndrome. It's just about right. You have to really think about these global constellations as the point, but you have to analyze them locally. While they're putting lots of satellites and capacity up, if you're looking at a given market, you have to take the local picture to understand them and understand that it's not going to take away everyone's business tomorrow. It's a nice augmentation, at least in Gen 1, to what we're doing. So with that, I'll take you through the last point of my presentation, which is this crossover into telecoms. And I think this is, I'm assuming, the most applicable to where you, the audience, sit, because telecoms is something that from a satellite industry always wanted to be, have a seat at the table. And I think now that seat is granted for a number of reasons. First, because of all of these positive moves and positive momentum around not just dynamics and not just constellations, but real different mindsets, different ways of thinking, tier 1 players are now partnering with satellite companies. And we mentioned Vodafone and AST Space Mobile, which is one of the direct-to-handset players that I'm sure you're hearing about. Verizon and AT&T, those are distribution agreements in the classical sense, and these are companies that see the benefit of extending their network with these constellation players. T-Mobile and SpaceX, this is the direct-to-handset business that will be launching, if you believe Elon, by the end of next year. And another one of these mainstream sort of applications of broadcasting right down to a T-Mobile handset. Apple and Globalstar, very interesting announcement on the iPhone 14 for connectivity just about anywhere if you have a view of the sky. It's not an indoor service, but for very, very thin route, sort of emergency, if you're hiking and you turn an ankle, something like that you can have this as applicable for, or lost, et cetera. This is what this is all about. But again, direct to a handset from satellite. And lastly, the whole cloud connectivity, cloud computing space has really entered pretty heavily into the satellite world, with Microsoft and AWS both having pretty extensive strategies for connecting, downlinking data from space down to data centers. Again, doing sort of the classic cloud strategies, but implementing them over a satellite link. And that's a very interesting move as well, because these companies move scale. So it's certainly not a low volume play for them. The point of plugging into carrier standards. So I mentioned all of this. We're still at its early evolution, early phases now. Just like we're in Gen 1s of constellations, we're in our early phases of trying to speak the same language, work from the same playbook as the telecom community. The telecom community today is homogeneous, scalable, all the buzz terms, software-defined, application-centric. All of those things make it, you know it, you live and breathe it. That's what I think the satellite world aspires to do, because today we are not homogeneous systems. If one network does not talk to another, it's not like your handset when you roam between countries or roam between even providers in your town, seamlessly doesn't drop a call. A Viasat terminal does not work on a Hughes system, does not work on Starlink, does not work on OneWeb today. And that's changing. And again, everything is so hardware-centric. It's the virtualization, we say software-based trend is coming to our world, but it's taking more time, driven by a lot of politics and other factors. And then the old world of selling megahertz, we're now really trying to sell the bits-based, so from hertz to bits and on demand as well. We're getting there. We're in our early evolution. So I think, if you jump in there today and expect it to be just like telecom, we're not there yet, but we're making good movement. And what's driving it? All of this disruption, abundant funding that's changing, as you know now, with the way that the financial world is, but it's still, companies still going public, some SPACs still that are happening. Standards, satellite world realized that we can't just develop our own standards. We have to have that seat at the table I mentioned, and 5G is a good example of that. The stakeholders, the GAFAM, Google, Apple, Facebook, Amazon, Microsoft entering the fray, all of them have satellite strategies now, all of them, and then some. There are even more not even in that list. And in the mega constellation phase. We did produce a white paper on this, and we can talk offline and I can point you to that white paper, but it's a good sort of initial landscape perspective on where we are as an industry relative to telecom. And the next piece is this direct-to-handset business, this direct-to-handset satellite connectivity you mentioned about. And there are two ways to think about it. One is on the left, using a mobile network operator's existing spectrum. Link, I told you earlier, they just received authorization from the FCC to actually provision service. They're not up in space yet, but they will be. AST launched a satellite not too long ago with a very big antenna reflector, it's called, on it, that allows it, by being bigger in space, allows it to broadcast down to smaller devices. Starlink we talked about, and that's the deal with T-Mobile. But the other side is these companies that have this MSS, Mobile Satellite Services spectrum, that are able to use it for this service direct to a handset, like Globalstar and Apple. Omnispace, a company you may not have heard of, also has access to the spectrum. So do Iridium, plays there today, Iridium, and then Inmarsat. So there are two ways to look at it. We see it as about a $67 billion revenue opportunity by 2031. In fact, one of our analysts who's brilliant at analyzing this world terms it as the largest satellite opportunity in our history, in the satellite world's history. And I believe that. I mean, this is the early stage of it, but I think it only gets bigger. But some things to think about, of course, the backwards compatibility of handsets, is silicon and chipset availability, which I know is plaguing just about everybody. Tech and performance issues, user perspectives on this. Are they really expecting to have this service from Apple and be on video calls with their friend over satellite? That's just not the case today. And lastly is the regulatory side of on the ground in each of the countries. Is it going to be authorized? Will it seamlessly operate as it would any other mobile service? Still things to work out, but again, early phase, as you sense a common theme here with all of this. So the bottom line, we use this bottom line terminology in the space world just to kind of boil it all down. And what's the key takeaways? Number one, space will be mainstream soon. It is, you could argue space is mainstream. I have GPS in my car. You think about satellites in general. Maybe you have your satellite TV client or whatever, but it is mainstream in the sense of every day on your handset, something that's coming very soon. SpaceX, in general, we can thank them for a lot, and the name it sucks a lot of air out of the room. We like to say SpaceX because they do things, they do it rapidly, and they're quite good at moving forward rapidly with a good product. But this is the entry point. It really opened it to the lexicon of everyday conversation. But now Apple, it's the ubiquity feature that we're thinking about now. It's important. Transformative 5G and constellations, reducing that friction for space-based services. And I know the telco world, that was their biggest beef with satellite connectivity. Is there's just so much friction for getting it integrated into your network. That's changed, and it is changing. And those sort of perspectives are being rethought today. And the constellations world, we can thank for that. And unlocking a lot of these new use cases that just didn't exist before. And the last point, it's really a food for thought more than anything. Defining a space strategy. If you're not in the satellite and or space world, and we define them, if satellites are orbiting or sort of man-made technology orbiting the Earth, space is everything else. If you don't have a strategy today, you really need to think about that strategy. And it can be a defensive one of, oh, I'm just going to compete, or you could be as aggressive as I want to invest in one of these sort of players. But the advice is really to think about it now, because all of this is coming one way or the other, driven by all that I mentioned. And because the fundamentals have changed, because all of the basics have changed, industry disruption, the disruption factor is underway in our world. So it's really food for thought more than anything. But we'd love to chat with you all. I get it offline. It's something that, again, it's near and dear to our hearts. So we're all space junkies and enthusiasts. So love to talk to you more about it, but hopefully that gives you some good perspectives. So with that ends my presentation today. David, I'm going to go ahead and turn it back to you, sir. Thank you.
Perfect. Thank you very much, Chris, for that informative presentation, and thank you to everyone who has tuned in to enjoy it. Before you go, I'll just give you a quick reminder that there are some useful resources that you can download as well. You're able to still submit any questions that you may have. Feel free to reach out to Chris and the team. They would love to answer your questions, and they'll be able to get back to you directly in email. One of the team will do that in the coming days. And lastly, I'll just let you know that you'll be redirected back to the event homepage, where you're more than welcome to select another session. So I hope you've enjoyed this session. Thank you again to Chris for his presentation, and we look forward to welcoming you to another session soon. Thanks again. Take care.
Thank you.